I'm going to start with answering some questions about the assignment. Okay. It is an interesting assignment, and as I keep on telling you, I'm happy with all the questions. My objective is that you understand not only what is required of you to do in the assignment, but you understand the whole network in which that assignment sits, okay? So, some questions from you. You're asking me, let's see if I remember, you're asking me, does the sign of the eigenvector matter? Remind yourselves of the linear algebra, all right? Eigenvectors are determined up to a multiplicative constant. So the eigenvector 1, 1 is the same as -1, -1. Eigenvectors represent directions. For those of you who know this, eigenvectors live in the projective space. They don't live in the Euclidean space. Okay? So the sign does not matter. When you put this in a computer, of course the computer has to go calculate something. Computers don't calculate things in projective space. They just give you numbers, and they follow an algorithm, and they will get a magnitude, positive or negative, a magnitude which is somehow random. It's not random, it's a consequence of the algorithm, but there's really no meaning in the sign of the components of the eigenvalue, or the eigenvector you will calculate. The eigenvalue, yes, of course, that's very important, but the eigenvector, no. The sign does not matter. You were also asking me about the logarithm of the returns. Is that what you were asking me? Forward rates, okay. So some people were asking about forward rates. Is the forward rate the same as, I don't know, something? The forward rate, we saw the formula here. So at the most primal level, for the forward rate, just follow the formula. You have to take a derivative and something, and use the chain rule, and that's it. That's the forward rate, if you follow the formula. Yes? It's a calculus formula, is the derivative of something. Hold on. Okay, so the forward rate is just that. You can say, well, this is the formula, and I get it. Good. But while you're at it, I encourage you to understand what forward rates are from a practical perspective. For example, someone was asking, can forward rates be negative? Can they be negative? It's a good question. You can ask yourself the question. You can actually answer the question yourself. They are the derivative of something related to the yield curve. Can you come up with a yield curve whose forward rate is negative? Yes, you can. In fact, it's not in the assignment, but I encourage you to actually create your own yield curve for which the forward rate will be negative. Why not? Yes? Okay, I know that you don't have ample time, and you don't have, and I don't know, between doing this or watching Netflix, I don't know what your choice is. I would do that. But that's for example. And then there was also a question about the covariance matrix, right? Yes, what was the question about the covariance matrix? Yes. Okay. Okay, so as I remind you something I said last week. The reason we take the log of the returns is because the series that's given to you is not an independent, identically distributed time series. It is autoregressive. And if you do some very simple statistical analysis of that series, you will see that it is autoregressive. But you should know that if you take a series which is autoregressive and you calculate covariances or correlations, things like that, you're going to get a misleading result, right? The correlation is meaningful when you have a series of IID, random variables. But if they're not, then they give you a misleading result. So if you're going to use the covariance matrix, you have to make that series IID. How do you make an autoregressive series IID? you look at either the derivative of the series or the logarithm. Right? That's the reason we do that. That's if it's AR1. If it's ARQ, then you have to take one division is not enough. You have to take Q divisions. You have to differentiate the series Q times. This should sound familiar from things you've seen in statistics. Am I right? Yes? Okay, so for that you have to go all the way there. Again, this is not a course on statistics. We use that, but the reason we take the logarithm or the return is to make our AR series IID. Okay, so if the assignment says take logarithms, take logarithms. If it says take returns, take returns. For the forward rate series, it will be the same. Okay, because there will be AR1 time series. Okay. More questions? You had a question? No, you're okay. Yes.
Are we allowed to use like built-in like libraries, like that automatically solve equations, for example?
If you're allowed,
Yeah.
you're encouraged. Yes. And if you want to create an app, I'll put it on the Apple Store. I will love that. You may get extra points for that. Okay? The Apple Store. Or Google Play. Yes. This is it's a good assignment. If you for your professional future, the more you're in command of every aspect of that, the better it is. There's some computational aspects, there's some mathematical aspects. I showed you how to interpret the eigenvectors of the covariance matrix. All of that has a lot of meaning. That assignment is actually a whole course in itself. Yeah. Okay, and I can see that many of you are, exploring the boundaries of that. So it's good. More comments on the assignment? Questions? There is no quiz this week. You're gonna get an announcement. You probably already got an announcement. There's no quiz this week. I need you to focus on the assignment. Do it as well as you can. I'll be teaching a course on communication. I'll be teaching a section on communication skills at the very end, and you see how important it is that you do certain things. For now, just spend all the time you can on that. Think of that assignment as your PhD thesis. That's going to go with you to job interviews and this and that. If you do it well, it really shows that you understand a lot of things. Okay? No quiz this week, there'll be a quiz next week.